Alright, so let's get into my 10-minute lesson. What we're going to do is we're going to talk about the definition of a derivative. And the definition of a derivative, f prime x, is equal to the limit as h goes to 0 of f of x plus h minus f of x all divided by h. Or f prime of x can also be thought of as f of x minus f of a all divided by x minus a, and this would be the limit as x goes to a. Now, the derivative is the core of modern of calculus, and it's one of the cores of modern mathematics. But the formula can be very scary and intimidating. And you know what's not intimidating? What's not intimidating is slope. You know, the thing we learned back in Algebra 2. The slope is simply rise over run, which basically is telling you the change in y divided by the change in x, or y2 minus y1 over x2 minus x1. And that would be the angle that one would see if they were to connect two dots. And you need two dots to make a line. So then you connect those two dots and you would kind of see the angle or the slope, or how fast the thing is increasing as it goes across. Applying this to the real world, this is the concept of speed. For example, if I were going at, let's see, at time is 8 o'clock and now I have 10 o'clock, and over here I have a distance of 5 and a distance of 12 up here. In that case, I'm going, what is that? Or I'm sorry, I put 125. So in that case, I'm going 120 miles, 120 miles in 2 hours. And so that's 60 miles per hour. Now, this would be great if everything traveled at the same speed and nothing ever changed the speed. The problem is that's not how the real world works. Take a ball and throw it up in the air. Watch its motion. If I were to graph, and if you were to throw a ball straight up in the air and then have it land back in your hand, if I were to graph the height versus time, it would look like this. Now, I know it didn't literally look like that. Maybe it went straight up and down, but remember, this is not a distance horizontal axis. This is a time horizontal axis. Here's the thing. How would you find the slope of a curvy line? Well, the first thing we need to do is define what a slope of a curvy line is. And what we mean by that is, let's say that we want the slope of a particular point, or a particular point on the curve, and we want to find the slope of a line that is kind of touching only at one point. Now, the old Latin word tangere means to touch or touching, and so we named this thing a tangent. So a tangent would be a point, or a line that only touches at one point on a curve. Now, herein lies another problem that we have. The tangent line is defined by only one point. Now, if I were to ask you, draw a line that goes through that point, you wouldn't be able to do it. You would have to say, you would say, well, I could draw this line. And then I would say, no, that's not the line I was thinking of. I was thinking of this line. And you would say, well, that's not fair because you only gave me 1 point. In order to draw a line, you need 2 points. So we can't just have this tangent thing and actually have a defined line. How do we even define a line that does that? So here's kind of what we're going to try to do. Let me switch over back to this thing right here. Adjust the computer. And then I've got a wire that I bent. And let's say that this curvy, ugly looking thing represents our function, and I have a bead on that wire. Now I want to find the the tangent line that is tangent to this point right here. But I don't have 2 points. So what I could do is I can just get another bead, and now I have 2 points. And as I can find the slope between this point and this point right here. And notice that as I move this bead closer and closer to that first point, the tangent, the slope, the second line that I'm creating, matches more and more with that tangent line that I was talking about. And as I get this thing incredibly close, it almost becomes identical. In fact, if I could somehow make it so that the distance between those 2 beads was almost 0, then those tangent lines would match identically, exactly the same. All right, let's switch back to the tablet so I can show you what I'm talking about. All right, so check this out. What we have here is we have some curve like this, okay? And we want to find the tangent line that looks like this. Now, this x coordinate right here we will call A, because that's the point we're interested in. And this right here, which is normally f of x, we're going to call, well, at this height, it's f of A. Because the height of this point right here is, well, whatever A is, and you just plug that in over here. Because this is your x values, and that's your A value. Now, that second bead that we're talking about is, say, right here. And the x value is right here, and then the y value would be f of x. Because this is the x value, and then that's the associated f of x. Now, in order to find the slope of a line that connects this dot to that second dot, we would simply do rise over run, which is f of x minus f of A, all divided by x minus A. And then what we would do is we would want to move that second bead closer and closer to the first bead. We want to move x closer to A, and that's why we say we're going to take the limit as x goes to A. Now, some of you are asking, oh, well, some of you are saying, wait a second, that looks familiar. That's exactly what that definition is. So there, we're not pulling equations out of thin air. These equations make sense. They come from somewhere. And this really is just slope, the definition of slope. Now, what is this h thing all about? Well, let me explain to you. Remember how I said, if I could somehow make the distance between the two go to 0, then they would be identical. Okay, it's a little weird to define the limit of something as x goes to A. But what I could do is I could say, this point right here, let's call it x now. And so this is f of x. And then this point right here, or let's call this distance h. It's the distance between the second point and the first point. So this second point is no longer sitting at x because that first point is sitting at x. This guy is sitting at x plus h. So his height is f of x plus h. Okay, well, the definition of slope is f of x plus h. That would be the height of the second point, minus f of x, the height of the first point, divided by x plus h minus x. And x plus h minus x, well, I'm going to combine like terms, and those guys cancel. And so that's exactly what I'm left with, f of x plus h minus f of x, all divided by h. And you're taking the limit as h goes to 0. Now, you want to see this in action. You want to see this applied. And I don't have time to do that, but what I really wanted to explain to you is equations that us math teachers give you, even though it may seem like magic, they don't come out of thin air. They come from someplace, and it might even be someplace you're quite familiar with. And that's What I'm really passionate about doing is trying to show you and debunk all of these crazy things about math so that way you understand where things come from. I hope that helps.